All right, guys, today we're looking at negative exponents. So we're going to start by looking for patterns in the table below. So here we have some negative exponents and some positive exponents, right? We know these ones over here. These is what we've been working on the past couple days. So if I take this 2 here and I apply 2 to the third, we all know that's 2 times 2 times 2, which is 8. If I apply the squared, that's 2 squared, which we know is 4. And if I apply the 1, that's 2 to the first, which we know is 2. Now, we haven't actually talked too much about the 0 power, but anything to the 0 power is 1, and that's a rule that you're expected to know. You can check on your calculator if you don't believe me. A lot of kids think that anything to the 0 power should be 0, but when you have something to the 0, it actually does wind up being 1, and I can prove it in the table because we look for patterns here. 8 divided by 2 is 4, 4 divided by 2 is 2, and 2 divided by 2 would be 1, so we can think of it that way. Okay, but now we look on the opposite side, and we get the reciprocal of all those numbers we just started out with. So 1/2, 2 to the negative first, is the reciprocal of 2 to the first. Okay, and then 2 to the negative second is 1/4, which is the reciprocal of 2 squared. And 2 to the negative third is 1/8, which is the reciprocal of 2 to the third, right? And if we continued into my dividing pattern, 1 divided by 2 is a half. A half divided by 2 is a fourth. And a fourth divided by 2 is an eighth, right? So that's how we would apply a negative exponent. It is the reciprocal of what the positive exponent would give you. So let's take a look at some more examples and fill out some more of this table. Okay, so here we have x to the n all the way to x to the third, like we saw in the previous one, and we want to apply a base of 3. So I already did 3 to the third for you. That's 27, and 3 squared is 9. 3 to the first, we all know is 3. I gave you 3 to the 0. So 3 to the negative first would be the reciprocal of 3 to the first, so that's going to be 1/3. And 3 to the negative second is going to be the reciprocal of 3 squared, so that's going to be 1/9. And 3 to the negative third is going to be the reciprocal of 3 to the third, so that's 1/27. Okay, so I want you guys to try the 5 to the n and the 10 to the n on your own. Raise your hand when you've got that done so I can make sure you've got it, and then you can continue with the rest of the video. So we're going to give an equivalent expression for each of the following, either in standard form or with an exponent. Let's do the odds together. So I'm going to write it two ways. I'm going to write it with a positive exponent and also in standard form. So as we saw by the table, when you have a negative exponent, it makes the reciprocal of the positive exponent. So I'm going to rewrite this with a positive exponent, making it 1/9 squared, because they would be the same. And I know 9 squared is 81, so this is equivalent to 1/81. Number 3, 2 to the negative 6 is going to be the same as 1/2 to the 6th. And 2 to the 6th is 2 times 2, which is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64. So that's equivalent to 1/64. Number 5, 7 to the negative second is going to be 1/7 squared. And we all know that 7 squared is 49, so it's equal to 1/49. 12 to the negative second is going to be equivalent to 1/12 squared. And again, we all know 12 squared is 144, so it's 1/144. Number 9, same idea, but now I can't actually evaluate it, so I just want to get rid of the negative. It's the same as 1/x to the 4th. So you're going to try the evens on your own. Again, go through it slowly, take your time, make sure you check in with me so I can be sure that you've got it before moving on to today's exit tickets and homework.